Hi, welcome to the last section of chapter 15, the inverse normal distribution. Okay, you should be proud of how far you've come because this chapter, it's easy but sort of confusing at times, right? So you guys have really came a long way. So the last section here, let's see what we have to do. So it is called the inverse normal distribution because instead of giving us, if you look at the previous examples or the exercises that you guys have done, they would always give you the mean. So this we have the mean as well, the variance with the variance, and we can get the standard deviation from the variance. And they said the shoemaker only wants 5% of people to be unable to find shoes large enough for them. So in other words, they need to make sure that 95%, so those 95%, they will be able to buy their shoes, so they're happy. Only this 5%, they will be unhappy because they won't have shoes that's large enough for them. At least this is what this company decides to do. Alright, so okay, the question here is, the question says, what is the largest shoe size gonna be? So you can see that questions that involves inverse normal distribution, the information provided for us is a bit different. So I would strongly recommend you guys to make a sketch. So do a sketch, just do a quick sketch. I've been recommending you guys to do that. And then just simply draw a bell curve. In the middle is going to be my mean. My mean is 22. So the mean size is 22 cm and the variance is 25. So in other words, my standard variation is 5. Square root of 25, right? So my variance is 5. Okay. So now what they're asking here is they want to cover at 95%. They want to cover 95%. So let's say today I cover all of this. If I cover all of that, I am covering 50%. Right? That is one of the special properties of normal distribution. The mean will cut it in half. So this is only 50%, and I'm going to take up maybe until there. Right? I'm going to take up additional 40%. So actually, sorry, additional 45%. So that in total, I'm going to have this in total, this whole shaded area is going to give me 0.95. Okay? But the question they're asking us right now, the mean is 22. The mean is 22. They're asking us, what is this size going to be? And that's going to be my maximum. That's going to be my largest shoe size, right? That would be my largest shoe size. That's what this is. Okay? So they want to find out. Okay, they want to find out how big should I make it be so that I can cover all the different shoe sizes until that one. So that's why we call this inverse normal distribution, because in the previous examples, at previous exercises, this is not a question mark. They will tell us, okay, let's say maybe this is a 42 or 45 or whatever. Alright, so they will tell us exactly what's that size going to be, instead of asking us to find it. Okay, so you might have guessed it already. I'm going to use my calculator. We have been using our GDC a lot, right? So just keep in mind that your sigma is your standard deviation is equal to 5. Let me just put it here. Alright, so let's do this. This is inverse normal distribution. So go ahead, turn it on, and let's go to distribution, second bars, and you see number 3. Number 3 says inverse norm. Go ahead, click on that. The area. What does the area give us? The area gives us the probability, correct? So the area right now is 0.95. Now what's my mean? My mean is 22. What's my standard deviation? The standard deviation is 5. If I paste it, enter, there you go. So right now this is not unknown anymore. This is actually, how much was it? It was 30.2. This is 30.2. Okay, so the largest shoe size is going to be 30.2, a size 30.2, maybe size 30 then. So if they make their largest shoe size to be, say, 30, let's just disregard the 2. I just say 30, shoe size of 30, they will be able to cover 95% of the people. And whoever has the people on this side, the people on that side, that's going to be another 5%. This is going to be 0.05. That 0.05 will not be able to buy any of the shoes that this company make. So as I have been saying, it is very important. It is very, very important for us to know what is. So now that I have this answer, what does it mean? What importance does it have? How is it significant? It's always good. We should always bring it back into context. In the next video, I will show you the following example. This example is a little bit more interesting. If you want, go ahead and try it out. But in this video, I'm just going to stop here and see you guys in the next video.